Mountains, the giants that shape our world. They rise above the continents like frozen waves of stone. Some are covered in forests. Others disappear beneath glaciers and permanent snow. Some were born from volcanic fire, while others were slowly pushed upward by the movement of Earth's tectonic plates. Mountains may appear permanent, but they are anything but still. They are changing every moment, shaped by tectonic forces deep beneath our feet, carved by rivers, glaciers, wind, ice, and time. And their importance reaches far beyond the spectacular landscapes we see. Mountains influence climate, store freshwater, shelter extraordinary biodiversity, and provide resources and livelihoods for billions of people. But how did these enormous structures come into existence? And what would happen to our planet if the mountains disappeared? How mountains are born. To understand mountains, we have to look beneath the surface. Earth's outer rigid shell is divided into enormous pieces called tectonic plates. These plates move slowly over geological time. When plates converge, enormous forces can compress and deform Earth's crust. One of the most dramatic examples is the Himalaya. The Indian plate continues to converge with the Eurasian plate, contributing to the ongoing uplift and deformation of the Himalayan region. This process does not happen overnight. Mountains are generally built over millions of years. In some regions, however, mountains can also form through volcanic activity, faulting, or other geological processes. So a mountain is not simply a giant rock. It is the visible expression of an active and constantly changing Earth. The Himalayas, a living mountain range. Few places demonstrate the power of geological processes better than the Himalayas. Stretching across several countries in Asia, this immense mountain system contains some of Earth's highest peaks. Mount Everest rises to approximately 8,849 meters above sea level. But height is only one part of the story. The Himalayas are geologically active. Earthquakes occur because the region remains under intense tectonic stress. The landscape is also continuously being reshaped by erosion. Rock rises, ice and water wear it down, rivers carry sediment away, and the cycle continues. In this way, mountains are caught in a geological competition between uplift and erosion, a process unfolding far too slowly for humans to see in real time. The power of erosion. Mountains are built by geological forces, but they are also destroyed by them. Rain breaks down rock. Rivers transport sediment. Glaciers grind against the landscape as they move. Over enormous periods of time, these processes can transform entire mountain ranges. Sharp peaks become rounded, deep valleys become wider. Rock is transported from high elevations toward rivers, plains, and eventually the oceans. The mountains we see today are therefore not only monuments to Earth's geological history. They are also landscapes in the process of being dismantled. Mountains create their own climate. Mountains do something else remarkable. They can change the weather around them. When moist air encounters a mountain range, it is forced upward. As the air rises, it cools, and water vapor can condense into clouds and precipitation. This helps create wetter conditions on some mountain slopes. On the opposite side, descending air can become warmer and drier, creating what scientists call a rain shadow. This is one reason why dramatically different environments can exist only a short distance apart. A lush forest may grow on one side of a mountain range, while an arid landscape develops on the other. Mountains are therefore not passive structures. They actively influence atmospheric circulation and regional climate. The world's water towers? Perhaps the most important service provided by mountains is water. Snow and glaciers can store water at high elevations and release it gradually as temperatures rise. Mountain rivers then carry this water into valleys, agricultural regions, ecosystems, and cities far downstream. This is why mountains are often described as the world's water towers. According to UNESCO's 2025 World Water Development Report, mountain regions provide roughly 55 to 60% of global annual freshwater flows. Around 2 billion people depend on mountain waters for their lives and livelihoods. The importance of mountain water extends beyond drinking. It supports agriculture, ecosystems, industry, and hydropower. In other words, a snowfield thousands of meters above sea level can influence the lives of people hundreds or even thousands of kilometers away. Life in extreme environments. At first glance, mountains may seem hostile to life. Temperatures fall with elevation. Oxygen becomes less available. Growing seasons become shorter. Yet mountains are biological treasures. Their steep topography creates many different habitats over relatively short distances. A mountain can contain forests at lower elevations, alpine meadows higher up, and almost completely barren environments near the highest peaks. These rapidly changing conditions create opportunities for specialized species. Mountain ecosystems are also important centers of genetic diversity. According to the FAO, mountains contain 25 of the world's 34 biodiversity hotspots. They also preserve important genetic resources for crops and livestock. In many ways, mountains are natural laboratories of evolution. People who live with the mountains. Mountains are not empty wilderness. For thousands of years, people have adapted to life in highland environments. Communities have developed distinctive agricultural systems, architecture, transportation methods, livestock practices, and cultural traditions. Terraced farming allows people to cultivate steep slopes. Pastoral communities move livestock between seasonal grazing areas. Mountain forests provide timber, food, medicinal plants, and other resources. Today, mountains also support tourism, recreation, mining, hydropower, and international trade. The FAO estimates that mountains cover about 27% of Earth's land area and are home to roughly 1.1 billion people. Mountain cultures therefore form an important part of humanity's cultural diversity. When mountains become dangerous, the same geological forces that create mountains can also make them dangerous. Earthquakes can destabilize steep slopes. Heavy rainfall can trigger landslides and debris flows. Rockfalls can occur without warning. In volcanic regions, eruptions can reshape entire landscapes. Glacial environments can also produce hazards when unstable ice, rock, or water suddenly moves downslope. These events remind us that mountain landscapes are dynamic systems. Understanding their geology, monitoring hazards, and respecting natural processes are essential for protecting communities. Modern science cannot stop earthquakes or landslides, but better mapping, monitoring, early warning systems, and land use planning can reduce risk. The mountains are changing. Today, mountain environments are experiencing rapid change. Climate change is affecting glaciers, snow cover, permafrost, ecosystems, and water availability. As temperatures rise, glaciers in many regions are retreating. This does not simply change the appearance of a mountain. It can also alter the timing and reliability of water flowing downstream. UNESCO's 2025 World Water Development Report warns that accelerating glacier melt, decreasing snow cover, and thawing permafrost are contributing to increasing uncertainty in mountain water systems. These changes matter because billions of people and countless ecosystems depend on mountain environments. Mountains are therefore not only witnesses to climate change. They are among the places where its consequences can be observed especially clearly. The future of the mountains. Protecting mountains is not simply about preserving beautiful scenery. It is about protecting water, biodiversity, food systems, cultural heritage, and human communities. Conservation requires cooperation between scientists, governments, local communities, indigenous peoples, and international organizations. Sustainable agriculture can reduce pressure on fragile slopes. Protected areas can conserve habitats. Better water management can help communities adapt to changing supplies. And scientific monitoring can reveal how mountain systems are changing before the consequences become irreversible. The future of mountains will ultimately be connected to the future of the societies that depend on them. The final journey. Mountains teach us something fundamental about our planet. They remind us that Earth is not static. Continents move. Rock rises. Glaciers flow. Rivers carve valleys. Forests migrate. Species adapt. And landscapes that appear eternal are actually temporary moments in geological time. Mountains connect the deep history of Earth with the future of humanity. They give us water. They shelter life. They shape climates. They inspire cultures. And they remind us of the extraordinary forces that continue to shape our planet. Perhaps the greatest lesson of the mountains is this: nothing on Earth truly stands still. Not even the mountains.